So welcome to our talk.
So we'd like to welcome you to our talk, Missing Pieces, Tips and Tricks on how to ensure your acquisitions aren't missing critical data. I'm Cesar Quezada, and this is Jessica Hyde.
So Cesar is fantabulous for first starters, and he has gotten into devices that otherwise wouldn't have been gotten into and found data that was missing regularly. So excited to partner with him on this talk. He's currently in 3 roles. He does R&D for ArcPoint. He's the senior technical exploitation officer at Mantech, working in a lab he's been working in for a very long time, killing it there, doing really great work. And he's a commander of an Army National Guard unit in the 133rd Cybersecurity Group. So true expert here. We worked together when we were both with the bases, and he's worked a wonderful amount of other places. George Mason, a graduate of their MS in computer forensics program and a cool reviewer for DFIR review. If anybody wants to help out with that project and peer review for the community, we'd love it.
Yes. And this is Jessica. I'm sure most of you, if not all of you, know who Jessica is, right? She's everywhere. She's founder and owner of Hexordia. She's also an adjunct professor at George Mason University, so she's helping grow the future forensicators out there and helping grow the field. She's been at Magnet, at Basis, at Ernst & Young, American Systems, and like I said, she's everywhere. She's even on TikTok now, so I'd recommend you go follow her.
Oh, that was embarrassing. Next slide.
All right, here's today's agenda. We want to touch on, why do we care? Why should you care about this talk? And then we're going to go into some real world examples of how data could be missing from hard drives and mobile devices. We're going to touch briefly on how to test it to determine if you're missing data, and then we'll wrap it up with some questions.
So why do we care? We care because if your collection is missing some of the critical elements of data, you're not going to be able to find all of the cool artifacts that were being discussed, like in Heather and Jared's talk earlier today. A lot of those artifacts can be missing if you don't have a fully inclusive acquisition. And a lot of times we are unaware that our acquisitions aren't complete. And so today we're going to bring you some tips and tricks to take care of that.
So we could say we don't know what you don't know, right? We can often say that something exists, right? If you have a picture, you have the picture, you have the metadata, you know it exists, but you really can't say that, perhaps it doesn't exist in other places, it wasn't sent somewhere if you don't have that data to look at, right? So that's why it's important to keep an eye out and always do proper investigations.
And when you don't have that complete picture, you can wind up making incorrect assumptions. It's also important, as we recognize, that there are times where a triage or a very specific targeted acquisition is necessary. So when we're talking about these times, when we're talking about missing data, we're talking about unintentional data that you're not acquiring, not when you're doing an intentionally targeted acquisition. There are definitely times when you don't want to wait to get the whole physical. If you're doing an enterprise collection, you're not going to collect every single computer, a full disk image, and look at them all to figure out what's going on. There's definitely a need for it. However, when you are working a case where you need to be able to provide to the other side data of possibly somebody being exonerated, if you don't have the full picture, you may be missing exonerable evidence. And I think that's really critical in investigations.
When we're talking about scope, oftentimes we are limited on what we can look at. If you are doing an investigation, you can look at from time A to time B. That's your limitation. Okay, so we accept that. But if you go and acquire that device from time A to time B, and that's all the data you get, you're going to be missing data when you go back to your lab, and perhaps you're doing that further investigation and you need to put pieces together that are outside that scope. So we often say to limit your collection on the analysis side, right? Get as much data as you can, and then limit yourself on the analysis side from time A to time B. And then once you're doing your investigation, you still have the additional data to go after.
I'm going to tell you why this really scares me. Because a lot of times there's tools out there that are like, hey, we're going to limit your scope on collection in terms of meeting data within a pair of timeframes. But if we go back to that, you don't know what you don't know. If you're limiting in timeframes, there's the possibility that you're not getting the data to third-party applications that are not supported by your tools that they don't know to collect. If you're able to collect that data and then limit on analysis, you're going to be much better off. But even more importantly, in some instances, there are databases that correlate to other databases that'll be outside of your time date range. Maybe a context database that's older for an application, it needs to be correlated with the messages database.
So now let's look into some examples of computers and hard drives and some data that we could be missing. So let's take, for example, the Samsung T drives, right? I'm sure everyone's used them. They're everywhere, right? The little Samsung T drives. Nowadays, they're coming out with newer technology. Now they have a fingerprint reader on there that can lock the drive to encrypt it. And some claims are that it doesn't work on Linux, even in Samsung's own documentation. But here you can see where it says it's only supported on Windows and Mac OS, right? So once you bring that drive into Linux, it's not a problem during our testing, because we found that even though Samsung's own documentation says it doesn't work on Linux,
it does.
It does, right? Right. So if you're working on a Linux workstation and perhaps it's not working for you, it does work. So here's a view of that drive when it's locked and now unlocked, right?
Sorry, I went too fast for you, sorry.
Locked, right? It's a bunch of unallocated space and it's not going to give you any data. However, when you apply your fingerprint, it's unlocked and all the partitions appear. There's not a problem. Here's another view of the Samsung drive, locked. And now it's unlocked. You can see it has FS events. So at some point, this particular drive was connected to a Mac, and here FTK Imager, again, locked. And it's important because if you're not aware of new technologies coming out, you could be plugging this drive into your computer. You could see that it's a bunch of unallocated space. You might think there's nothing on here or something's wrong with the drive, when in fact it's just you need a fingerprint or some other security measure needs to be unlocked for you to take a look at it.
And something key here is that even in the lock, there appears to be data. So you could be misguided and think that it was just a less used drive if it's unlocked. I want to get into something that's going to be mismatch of compatibility of things where you may get missing acquisitions. So how many people out here have really upped their speed and are using USB 3.2 Gen 2x2s, getting at 20 Gbps? All right, I see a couple hands, fast adopters of technology, right? So if you run into one of these in a while, these are going to give you 20 Gbps, 20 gigabytes per second, versus the 10 gigabytes per second you're going to get with regular USB 3.2, which is really confusing because USB 3.0 was renamed. Anyway,
So many times.
So many times, 3.0, 3.1. Oh, now we're 3.2 and we don't care if you're backwards because it's 3.2 Gen 2. Anyway, if you have in evidence a 3.2 drive, it is backwards compatible, 3.2 Gen 2x2. It is backwards compatible, and you'll be able to image completely and normally with a USB 3.2 Gen 2 receiver. However, if you are those fancy labs and you are like, woohoo, I got the speed, and you really only get that speed when you're matched, guess what happens when you're matched with this new technology? It drops bits without your knowledge. You're not going to get consistent hashing, imaging the same drive over and over, and you're actually going to need to plug that in instead to your 10 Gbps port to do your collections, or you can be losing data. And that's really crazy and scary. And I don't think people are aware sometimes when they adapt technology and go, oh, I'm getting the fastest, they don't realize that that speed is dropping bits.
All right, and here's another example where we have the same hard drive. So that's the same hard drive in both those pictures, right? We have a StarTech adapter that you can buy anywhere. It's just an adapter to read the hard drive. And on the right side, you have the hard drive and its enclosure that it came in. We just took the case off for the purposes of the picture. So we imaged the drive first with the StarTech adapter. This is the hash that FTK provided us for the imaging of the entire drive. And then we plugged it into with its adapter, hard drive enclosure adapter that it came with, and it gives us a completely different hash. So that is clearly not, something's wrong here. So here it is in Linux. We're looking at the different partitions here. With the StarTech adapter, not a problem. However, with its original hard drive enclosure, we have a warning that the backup GPT table is corrupt. And there's one less sector in this acquisition.
So you're actually missing a sector by using the native adapter instead of putting on an acquisition adapter.
Right. And so here's the look in FTK Imager. The last sector is in red. This is the StarTech adapter. And here it is with its
Sorry.
native adapter. That is the end of disk of the adapter, right? There is no additional sector. So that adapter is cutting it off logically, and it's discarding that last sector for itself, for its metadata and what have you. So that's just something to be aware of whenever you're imaging in a drive with its own adapter in it.
Okay, this is the one that scares me. So in 2017 on this stage, Courtney Webb came and did a fantastic talk that I encourage you all to watch, called Implications of Firmware Trickery on Hard Drives. And the TLDR on that is that a drive can come labeled as a 1 terabyte drive, but be on a 2 terabyte disk. This is to save money. And there are utilities out there that will allow you to go ahead and store in that additional space. But then when you plug in the drive for recovery, it'll still look like that original 1 terabyte drive. There's also tools like HDD Hacker that allow you to alter the drives at the firmware. So most acquisition hardware utilities, a lot of them will not catch this and get the second utilities, but there are some that will go ahead and look at the firmware and allow you to think it. So basically you can be fooled into thinking that the drive is a different size, or it's two different scenarios. You can take a drive that's a known size and alter it, or you can take a drive that the manufacturer has shortened because they're using the same physical disk to share, but they're changing the sizes.
So in an example of a device, perhaps that's new technology, right? We'll look at the Microsoft Surface. We get a piece of evidence, a new technology back in, a few years ago when Microsoft Surface first came out. You couldn't know how to image it. We had no idea how to image this device. It was brand new. It had one USB port. It was a problem. But thanks to the community, and this is a very sharing community with all the parsers and tips and methodology, someone out there posted a walkthrough of how to image this device. So now we pretty much use this walkthrough today, right? We needed a powered USB hub, changing some settings in the security settings, external drive, keyboard, and mouse. So relying on other examiners who are more knowledgeable and who have been around the block a bit more is very helpful for acquiring new devices that perhaps maybe you wouldn't be able to get if you were working by yourself.
Not all of these methods are going to work like you think they're going to work. So I've had the luxury of spending a lot of time digging into Chromebooks over the last several years. And Daniel Dickerman came out with this incredible method of acquiring Chromebooks that's based on a custom recovery. It's great, peer-reviewed work. I've used this method multiple times. Fantastic, except when you're doing this method, the Chromebook writes out the data to what's left on the drive before writing it out to your external media that you're copying to. So if, let's say, you have a 64 gig hard drive, okay, on your Chromebook. And by the way, if you think all the Chromebook data is in the cloud, it's not. TLDR, I've got lots of stuff on that. So you're acquiring the Chromebook, you get the 64, you've got 64 gigs, 50 of it is used. That means you've got 14 gigs. Your acquisition is only going to be 14 gigs and your tools are not going to notify you. So if you're not logging in and checking that disk size, you're going to be short data. In the opposite, if you only had 14 gigs of use, it's going to write you out that 14 gig image. You're going to have everything. And there is your tools, your methodology. You're not going to get a warning that you're not getting all the data. And that's really the key to what we're talking about.
All right, so now let's take a look at mobile devices, something we all love and hate, right? We love them because they give us a lot of information, but we hate them because it's information overload and sometimes they're hard to get.
So when we're talking about mobile devices, we're going to talk about the difference between the different acquisitions. And the problem is the terminology is a little different than you may see in typical computer forensics. So I'm going to share the terminology that I personally know and teach because I think it's the most applicable to understanding these differences so that we can talk about then the differences between the data you're going to get in these acquisitions and when you need to get them. So for mobile images, you've got the physical, the logical, and the file system. And physical and logical and file system do not mean the same thing here as they do in traditional dead box computer forensics. So the definition we're going to use here is that a physical means that the data is pulled directly from a connection to the device's storage area. It is reading the data from the storage area directly. A logical mobile forensic image means we're pulling the data via the operating system, and that's data as interpreted by the operating system. This is also controlled by what the operating system is trying to let you get back. Included in this area would also be if you're doing iTunes backups, if you're doing any kind of backup, if you're putting an agent on a device, anytime you're communicating via Android or iOS to get the data, you're getting that data as interpreted by the operating system. There's several methodologies here, be it on an old school AT command to doing APK downgrades. There's a lot of different ways to collect data logically, but that logical data in this terminology is going to be as collected by the operating system. Very different than the term logical in computer forensics, which is actually more synonymous with the term file system image in mobile forensics. So a file system image is going to be the collection of all the active files and folders that exist on the drive. Now, if you're used to the computer forensics world and not really to mobile, you may be thinking, well, that's going to mislead it. Not really, because on mobile phones, a lot of our data is happening in databases, and those records still exist within the file. So there's going to be lots of remnants of data and non-user data as well. You can get that complete picture. So for us, really today, the full file system image is really the gold standard because we don't get a lot of physicals anymore because of encryption. Right. Or they're useless. Older devices, yes.
So an example that Jessica and I always like to talk about is we had a case once where we had an Android phone, and this was a very hot case. I'm talking, they wanted the data yesterday, right? It was in the news hot. So we took a look at it. We took a look at our tool. The tool said, yes, we can get you a full physical of that device, no problem. So we plug it up, we start the acquisition. And in the meantime, we're going through all the typical websites you go to for mobile devices like GSM Arena or Phone Scoop to look up the specs and to verify, what we have exactly going on here. The websites tell us we have about 16 gigabytes of data that we should be expecting for a image of this device. And then our tool finishes and it says, great, we got all the data, all 1 gigabyte of data. So there's a little bit of a discrepancy there between the 16 gigs and the 1 gigabyte of data. So in the end, we ended up having to use a Mac and terminal into that phone to DD the 16 gigabytes of eMMC that were on there. And plus the 1 gig that the tool gave us, which was an additional, we actually ended up with 17 gigabytes of data versus that even the 16 gigabytes that the websites told us. So it's just something to be aware of, that you shouldn't always trust the tool, even though it tells you, I can get all of it. Sure, it got all of it, but we were still missing, missing a whole nother storage area.
And here's the deal, right? If you're noticing a pattern, it's we got the data, but then we realized we were missing some, and we looked and we researched and found out there's actually more data to get there. How do we now get this, right? And we were actually able to just see that eMMC via the terminal and just DD it. It was actually relatively simple once we figured out that data was there. I want to state really quickly before we dig into this. Yeah. There is value to doing a triage extraction. There is value to doing a quick logical and not getting all the data at first, because it's easy to manage. You can look at it. You can inform your interviews. I always try to pause myself and stop myself from saying interrogation. Difference in the worlds that you work in different times in your life. So, that information can inform. But when we get to Android, let's talk about how the differences are between these. So we're going to talk about all the differences between different artifacts and what you're going to get in that logical versus that full file system. Oh my gosh, my data is not showing up on the screen. Oh, that's bad. Okay, so let's see what Jessica can do from memory, because my slides, which looked fine yesterday, are actually missing the blocks below that are going to tell you what's going on. So luckily, hopefully I know what the heck I'm talking about. So when we're talking about GUIDs, so your MSISDN, your IMEIs, those are all going to be present in both your logical and full file system extractions, as well as your PIM data, except for call logs and notes. All of your call logs are going to be present in both. Your SMS messages are going to be good. You're going to be good on MMS messages. Where you're going to start to see a difference is your standalone files. You're going to get partial recovery in your logical versus your full file system images. When we talk about application data, you are going to have wide discrepancies. This is because some applications are going to share that information in backups and others will not. And even when you have that shared data in backups, it's a difference between if they're exporting the entire full file system or not. Very similar to what we're going to see in social media. So in social media, application data, these are both areas where you're really going to need the full file system if you want data from your additional apps. So for example, WhatsApp data does appear in backups, but you won't get Signal data, for example. Communication app data, kind of what I was just talking about, that's going to differ. Internet data is going to differ, and this is really interesting because you may think that you're going to get all of your browser history in a logical. You won't. It's going to be much more enriched in a full file system. On Android, you need a full file system for email. OS and app activity, if you want the really cool stuff like usage stats and recent tasks, usage stats is going to show up in full file system. Recent tasks is going to be partial in logical. Deleted files, if you really want to pull those archives, like I said, those are going to be in those files that you're going to recover and you're going to scrape through. So you're not going to see that data in your logical. You need your full file system.
So we're going to move into iOS now, right? So with iOS, we have a couple additional columns to look at. So we're going to look at still the logical and the file system, but now we're going to look at AFU and BFU, which is after first unlock and before first unlock. And just real quick overview, after first unlock is when the phone has been rebooted and the passcode has been entered at least one time. And before first unlock is after the phone's been rebooted and it has not been unlocked. And depending on those states is how much data you'll get.
Now, this I'm going to admit, my memory is not going to be as clear as what's between BFU, logical, AFU, and FFS without it on my slides. So this will be fun. Equipment user data, you do get them all. PIM data, I know you get both an AFU and full file system. So I believe that you get some of your notifications in BFU, but you don't get full, it's a partial. Call logs, you're good off, you're partial in BFU. SMS, your logical AFU, and your full file system will be complete. I am going to have a link at the end of this slide deck. There's a QR code, and you'll be able to see these tables incomplete. Not incomplete, completely. I speak so quickly, there was no space between the word in and complete. You will completely see all of these tables populated in that PDF that's available there. So you'll be able to see the difference between MMS, where each one of these files are for each of these categories. The TLDR on each of these, there are some interesting ones. So like when we talk about communication app data, a Snapchat, for example, you can get some of the data in BFU and not in logical, but you'll get it in AFU and full file system. So between BFU and logical, what you get is going to vary. The TLDR on this is your strongest extraction is going to be your full file system every single time, but you can get so much data from AFU. And Cesar just went through the difference between BFU and AFU, and what that really means at the end of the day is that you cannot have that device die. So sometimes folks will be like, oh, I recovered the data, I recovered the phone, seized it from the scene, I put it in its Faraday bag, I've isolated from the network, no one can send a wipe command, yes. But they didn't put it on a charger. And if you don't put it on a charger and that phone sits in the Faraday bag, that battery is going to drain. And once that battery drains and that device is now in that BFU mode, even if it's locked, a lot of your forensics tools, or at least two of them, will be able to get you an extraction, even though the device is locked. That extraction, if it is before the device reboots, so you keep the power on it, it was unlocked by the user before you seized it and had not had a power up, you are going to get great data, even without cracking that password. So before you even brute force it, so you can start looking at that data. But if you let that battery drain out, you're going to get next to nothing. And that's what's on all these slides that aren't there. So that's my passion to talk about it, especially GPS data. The TLDR on this is if you want all of the incredible artifacts that Heather Mahalik and Jared Barnhart were just showing in their last presentation, you need to have that full file system. Yeah, let's talk about retention.
All right, so in an example of, did the user change a setting, we're going to take a look at this mobile SMS P list, which denotes the iOS message retention. So by default, iOS will ship you the keep messages for days as forever. That's how it comes to you as without the user ever changing it. So we wanted to see if we could determine if the user ever changed it. So we imaged the device and the keep messages for days keys in that P list was nowhere to be found. It doesn't exist there. So we changed the option to 1 year, and then all of a sudden that keep messages for days key appears with a value of 365, obviously for 365 days in a year. We imaged it again, changed the option to 30, and now it has a value of 30. And finally, we changed it back to forever. And now the keep messages for days key appears. It's still there, but now it has a value of 0. So now we know that the user did change it at some point. We just don't know any additional data after that.
Well, this is important because now you know that your collection, there's data that it doesn't contain, and you need to find other ways to validate the data. The problem is you don't know what period that was on or off for. So here's the big issue. You've got that device and you kept the charger on it. You kept that device AFU. Yes, we're going to get all the data. So because you've got that battery on it, right, you can just leave it on the shelf. No. These databases, the rich database sources that you heard about in the last talk, they drop data. Every single day, you are losing data from a period before. Safari history retains 30 days. Now, can you carve additional data potentially from the database? Yes. But the active records, right, live records versus not live, those are going to be a 30-day history. So every day you go, you're going to drop a day past. There is a weird thing if the same website's been visited way past before the 30 days and it was continually visited and never dropped out of 30 days, it will maintain timestamps from before. So if you see that, don't necessarily think that you didn't lose that data. You did. It doesn't mean your database goes back that far. Deleted photos, they're on the device for 30 days so that the user can put them back up. After that, they're going to be gone. Knowledge C, all the incredible work that Sarah Edwards has done on Knowledge C database and shared with the community that Apollo parses, fantastic rich artifacts. They all kind of range between 7 and 28 days, depending on how long a shelf life they have. Cache locations, every single day, you're losing cache locations. The call logs, there's some variance by carrier, but they are dropping day by day. So TLDR on this is, when are you going to acquire that device? As soon as freaking possible. It should be ASFP. Sorry. Because you need them.
Right. So now we're going to touch on how do we determine, if our devices, if we need to do additional steps to get devices or we're possibly missing data.
So the first thing, and Cesar touched on this when he was talking about the surface, is you need to listen to the community. There's no way to really know about the fact that your Chromebook acquisitions are going to only go as far back as the period that you have written on the disk, because the methodology writes the disk before it writes out, if you're not following what's going on in the community and looking things up. If you are not on Twitter, please get on Twitter. Follow hashtag DFIR. It's the best way to keep up on what's going on. That's where people share it. This Week in Forensics is a blog ran by Phil Moore that talks about all, well, it doesn't talk about it, lists everything that comes out from the community. It's like 200 some odd things the community puts out each week. I do read it weekly, but that's not how I use it. If I'm looking at a device and something doesn't seem right in my acquisition, I use that as a search query to find the blogs that people, practitioners, other people have put out for the things they've seen. The Digital Forensics Discord server has over 10,000 forensicators on there talking actively about the problems and solutions they're seeing. Search that, read it, become familiar with it. If you have a specific, it's very broken down into categories, so you can actually have the conversations where you are. But the big thing is if you don't see the data you expect, if your drive or your collection size is less than you want, and it's actually one of the advantages of not doing a targeted collection, is you should be able to determine what the total size should be. And even if that means, yeah, you've got to log into that Chromebook Live, right? Yeah, you need to research what size the manufacturer actually uses for that drive and if they partition down in the firmware, so that you can ask those questions when you see what you don't expect. We are talking about a lot of scenarios. I know we didn't give case examples. That's more due to the cases we work that we can't really discuss them.
Yeah.
But these are things that we've ran into time and time again on actual cases. And the answer is when something doesn't look right, you need to get that exemplar and test. You don't want to be testing on your device. So I'd say one of the most critical things to being able to discover and get through this is really ensuring that your exemplars have a little flexibility and you think about what other ways can I look at this. If you are running into a problem because you're doing a Linux collection and you're seeing a GPT table that's not working and is corrupted, what other way can I try to do this collection to see if I can get that space? You need to really think outside and say, well, let me try this, and do it with an exemplar that you've populated, you know what's there. When you populate data, document, 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 and more importantly, if you can, please share those data sets back out with the community so they can use them as testing and reference test sets. Thank you, Joshua Hickman, for all of the data sets you've contributed to the community. And then once you're done populating your device, you need to go ahead and validate your assumptions. One of the biggest problems that I see with testing for this particular scenario is unintentional inserted bias. It is very difficult to sometimes think like how somebody would misuse a device, but it's really what you need to do to see that and then try to misuse the device to validate your assumptions.
So in summary, just to wrap it all up, triage images are valuable, but they won't have all the data. So try to get that, full file system if you can. And once you have the image, make sure to take another look at it. Make sure it's not encrypted. Make sure it opens up in your forensic tool.
I mean, I think about all those old Blackberries, right? There were all these old Blackberries that you would get a full physical. Tools were good at giving me full physicals of Blackberries, but there was nothing out there that would parse them. So I needed the logical. The logical was more appropriate for all of those freaking BlackBerry World devices.
Right. Tools may not be self-aware that a collection is incomplete. An example of the Android, right? The tool thought it did its job, it got the full physical, but during, after
it did of the one chip,
right? But we were missing 16 gigs of data, so that's a lot for a phone. In the example of Surface, the examiner's knowledge is critical, right? We didn't know how to image that device, so if we would have just relied on ourselves, that piece of evidence would have sat there for a long time. But we looked in the community, looked exactly, how can we get this device acquired, and we're able to figure that out.
Right. At the end of the day, our job is not just to follow instructions as to how to acquire devices and to look at the data from the tools. Our job is to question what the tools are doing for us and see what might be missing. That is our role. Otherwise, we could all be automated out of our jobs, right? Let's be real. Our role is to figure out what else isn't there, what is new, what is missing.
Right. And the state of the device is important at time acquisition, just so you know what to expect. AFU, BFU, logical, physical, you need to know that so you know what to expect when you're getting that data.
And if you really want to know what to expect, please pull the slides where the data actually is instead of the 20 blank slides I had in there of that.
We promise it's there. And then from time to seizure to acquisition is important, right? As soon as you get that device, you want to try to acquire it immediately. Even if you have it in a Faraday bag, airplane mode, even if it's powered on with a battery, it's going to lose data day by day. So you want to try to get an acquisition as soon as possible. And with that,
Yeah, so first off, please scan that QR code if you want the slides or just see us.
Yep.
I'll give you my card and email me and I'll give it to you. I actually have a tap card. You could just fill in your email address and I can send it to you. So apologies for those slides being blank. But if you have any questions, we're happy to take them now. And also 100% the best place to reach us is on Twitter. So there are our handles.